Hi everyone, welcome back to my channel. Today's video we are trying to dive into a technique that changed, let's say, the neural network training, which is batch normalization. But don't worry, I'm here to simplify the concept so that you can understand it 100%. So whether you are a beginner or has experience, this video will break down a batch normalization in a way that easy to understand and easy to grasp. And guess what? I want you to join in. Feel free to ask questions, leave comments, and share your thoughts in this chat. So let make this a fun and interactive learning experience together. So let's start. So what is the batch normalization? The batch normalization is a technique that normalizes the input of each layer in the neural network. So by doing this, it will try to reduces the internal covariance shift. So the change in the distribution of the network activation due to the continued update of the model parameters. This makes the training faster and more reliable. So, before diving into the patch normalization, let me just make a short recap of the what is the normalization and what is the standard deviation. And the normalization is trying to scale to scaling the input into a 0 or 1, or maybe -1 and 1. So it's in a fixed interval. But the standardization, it's transforming the data, the input data that have mean 0 and unit and standard deviation 1. And this is, for instance, the formula here. I will just show you an example in a moment. And when to use this normalization, you use it to bound it your input like image pixel scaling. And the standardization is used in the batch normalization when your model assumes that the data normally distributed. And as you can see here, this is sensitive to the outliers, and this is not. And this is used for batch normalization. So once you see batch normalization, it means standardizing the data or transform your data into that have a mean equals 0 and standardized deviation is 1. So let's assume that we have this example here, this factor here, 10, 20, 30, 40, 50. Now we need, let's see, to minimize to normalize it. So minima, we need to give the minimax. So the minimum is 10 and the maximum is 50. Let's see, and the result of this using this formula here. So x minus the minimum of the factor divided by max of the x minus the minimum of the x. So as you can see here, 10 minus 10, so this is the minimum, divided by the 50 minus 10, and you will get this output of the normalization. As you can see here, it's between 0 and 1. So because we have mini-max scaling. So the standardization or z-score scaling, it's that we will calculate the mean of this. So the mean of this factor here, and also the standard deviation of this data of this factor here, and the result will be applying this x minus mu, which is the mean, divided by the standard deviation. And you can see this is our result. So this is before the standardization. This is our original data, and this is after the standardization. So now, if you calculate the mean of this, you will have 0. If you calculate also the standard deviation, it will be like this value here. But let's say it's almost 1, so it will be considered as 1. So let's just have a look in if we have data. Let's say you have a data set of house pricing, and this is few features here. So now, how to do the standardization? Standardization, it will take each feature and calculate the mean and standard deviation of this, and then apply this formula here to each value. So as you can see here, this is the size. I mean, I did it for the whole data for the all columns. But let's see, this is the original data, and this is after the no the standardization, or let's see, yeah, standardization. It's batch normalization, and batch normalization, as I said, it works only for features. So each features you have to calculate the mean and standard deviation, and you will also do it for this and for this. This called, let's see, I will just keep it simple to batch normalization. And what is the layer normalization? So I will explain it in a next video in a more details. But layer normalization, it will take each input as alone. So it will take, for instance, the calculating the mean and the standard deviation of each sample. And let's go back to our example. So now let's talk about when to use the batch normalization. It's typically applied after linear or convolutional layers, but before the activation function. Let's see, like ReLU activation function. Because of these layers often produce outputs when with varying scales, which can slow down the training. Batch normalization steps it stepped in the normalizing these outputs and making the network convergence faster. It's especially used for big data and complex model. So with it's try to make it let's say help the model to train more efficient. So assume that you train your model with big values, let's see. And is there any difference? Let's say, for instance, if you do this, use this in the training, and maybe use this one here. Which one is easier? For instance, if you multiply 50 by 50, it will be a big value, and if you multiply this one by point 4, it will be faster. Now, let's see. This is if you follow up from the beginning, you see this is the image, and this is the filter, our filter or kernels, and this is the features map, and from here, this features map we will try to apply. Let's see. This is the after convolution layer, and we will apply the batch normalization. We will try to normalize each channel. Let's see, and before the reload function. And I have a small example, or let's see, I'll see more effective, let's see, scenarios here. So assume that I have 10 batch, 1, 2, 3, 4, 5. This is 10. Let's see, 1, 2, 3 till 10. And in each batch I have three channels, just to make it really simple. And each let's see channel, let's see, this is the 1, 2, 3 channels, and in each channel I just assume that it's 32 by 32. Now how the batch normalization is working. So as I said here, I have 10 batches. Now I will try to calculate, I mean, do the batch normalization for each channel in this batch. So I have 1, 2, 3 till 10. So I can see here I just take only the red. Let's see the red channel, and I will see how many values. Let's see in this in this 10 images, or let's say 10 channels. Uh, Not 10 channels, but 10 red channels. Let's say make it like this, and you can see here number of channels is 10, and width and height is 32 by 32. So it means I have 10,240 values in all of these channels, not channels, and all of these red channels. Let's see, and I will try. Let's say this, for instance, this is a matrix, this is a matrix, this is a matrix, and this is one matrix, 2D matrix. Let's see. And how many values we see here? We have seen 10,000 something. Now I will try to calculate the mean of this all of these, the values all over these slides, and also calculate the standard deviation, and then updating the values of each pixel with this formula here, as we have done it in, let's see, in this example here. So for instance, this is the the result. For instance, the value minus the mean divided by the standard deviation, and here is the same for each pixel. Let's see, assume this, we will take the firstly this one here. This is the first pixel, let's see, and I will do this pixel minus the mean divided by the standard deviation, and I will have the value. I will put it here, and I will go through the next pixel until finishing this. Now I will go here. I will see the x, this pixel minus the OD calculated mean divided by standard deviation. This is calculating the standard. Let's see, standardization, the channel, the red channel. Now for the training, we have to keep our let's see, uh, there are two parameters indeed we need to keep. We need four parameters: mean and standard deviation, plus plus these are the scalable parameters we need to keep this. For instance, this the scale parameter for this channel, and the scale parameter for this channel, and for instance this is multiplied by the output of this. Now this is for the red, or let's see, for the first channel in this tensor here, and we will do the same for the next channel and also for the third channel. So, and each channel has, let's see, has four parameters. For each patch, let's see, it will has four parameters: one, two, and three, four, and this will be updated over time, of course. And let me just show this. So let me just like this, and let's see what happened during the training and testing in batch normalization. So during the training, batch normalization compute the mean and variance for the each mini batch. So you can see the mini batch, it means for instance I have here 10 batches. And please take care, you need to have no, we will discuss it later, yeah. This is a tip. And as I said, for each mini batch, we'll calculate the mean and covariance, and updating the running average. So let's say, assume this, we have 10 batches, and we will have let's see 100 ebooks. Let's see, and our running average, it will try to update the average of all of these batches. And during the testing, instead of computing the mean and covariance for the test data, the batch normalization, it will be still used in the testing as well, but we will use the running average that calculated during the training. So this ensures the consistency and avoid overfitting in the test data. So because assume that you will calculate the batch normalization for each batch, it will be maybe overfitting. But we will use the already calculated running average calculated from the training dataset, and it will be also saved in the model. And let's recap. Let's see how to. This is the use cases and tips. So try to use batch normalization, or BN, after the convolution layer, and before the activation, of course. And place the batch right after the linear or convolution layer, but before the activation function. And in the PyTorch, try to keep the track running status as true. This ensures that the running average of mean and covariance are updating during the training. And for small avoid to use it with a small batch size. So assume that in this example I have 10 batches. I will see it's good to have it 10, but assume that you will use it with one. So this will for a very small let's see batches, it will try to make the network not effectively, or let's see uh, it will have the different distributions, and you need to update it, and you need to to do it, to work it to do the training for a long time, and it might be not working. But that's why try to avoid this with a small batch size. And this work perfectly with the SGD, which is called stochastic gradient descent, and Adam enhancing the performance. So, by understanding the batch normalization, you will not just speeding up your neural network. You also ensure that these are they are robust, reliable, and ready to tackle this. Let's say when even when the most complex task. So try to normalize your data, to normalize your batches, and watch the model to know height. So also you try to visualize the model, the let's say the output, and maybe the loss function with normalization and without normalization. So thanks for watching, and please subscribe to my channel and like the video. And if you have any question, please drop it down in the comment below. Thanks for watching, and see you next time.